So let's continue graphing our aggregate expenditures in Python. Again, we are at drstephpowers.github.io/econ in Python. If you want to work alongside us in the Python workbook, simply click on aggregate expenditures, then go into Google Colab. That's a little button here at the top. And you will need to log into your Google account and save a copy of the worksheet. So you're working on your copy in your Google Drive. And so as you make changes and you want to keep them, then you'll want to hit save so that you have your own copy with all your information on it. So we did C and I and G, and now we have exports and imports as the last part of our aggregate expenditure function. So aggregate expenditures, total spending in the economy, is consumption plus investment spending plus government spending plus exports minus imports. So we want to look at who buys the goods and services in our economy, and so we have to subtract out the amount of goods we buy from other countries when we're looking at calculating that total spending. Ultimately, we're trying to derive the demand for goods and services made in our economy. So we have exports and we have imports. This is data from the very top from the table. So we simply need to enter in the values for the exports and the values for the imports. We are going to plot, and so you need that import matplotlib.plt. So just go back if you did not run the earlier code, all the way back to the top. You're going to need to import matplotlib.pyplot as PLT. The other thing you're going to need is you're going to need the linear model and NumPy as NP. Those packages you'll need for finding the formulas. So if you didn't run the previous codes from the previous videos, make sure that you do install those packages. All right, so we are going to plot. We're going to plot national income on the horizontal and exports on the vertical. We're going to plot national income on the horizontal and imports on the vertical. We'll label national income for the x-axis, export and import spending on the vertical axes, and we have two lines on our graph, so let's have a legend. Remember, with your legend, whatever order you told it to plot needs to be the order you provide the labels. So if you're going to have exports be your first plot, then export spending is your first label. Again, the rest of the plt.legend command is simply to put the legend below, shift it over, and to have two columns because we have two labels. All right, let's run this. And we get this graph here. We can see the blue is export spending. Notice that it does not change with income. That's because export spending is people in other countries buying our stuff. It doesn't depend on our income. It depends on their income. And so you can see that when our national income changes, export spending does not. So it's a horizontal line. Based on this, we would expect the formula for export spending to be x equals 100. And then it has no slope. So it's just x equals 100. So we'll prove that in just a second. The import spending, we can see that as our income increases, we buy more from other countries. This is all the travel and vacations and foreign goods we want to bring in. Notice also that import spending has autonomous spending. So when income is 0, we still do import spending. And that's because we can't make everything we need here. So even if our income is 0, we need to import things, fresh fruits and vegetables in the middle of winter kind of thing. So there is autonomous spending, spending that is done independent of income. So let's find the formulas for these graphs. And one more thing before we leave this graph itself is that we can see here at a national income of 600, we have a balance of trade. Exports are equal to imports. Notice that at lower levels of income, we export more than we import. And so here we have a trade surplus, more money coming in than money going out. At higher levels of income, notice that the import spending is higher, the export spending hasn't changed. So here we have a trade deficit, more money going out than is coming in. So trade deficit, trade surplus, balance of trade. All right, let's find some formulas for these functions. Okay, so we need, in order to use this linear regression formula, we need to convert that exports into an array. And if we haven't already, we need to convert the national income. Go back in my code to figure out where I did that last. That national income needs to be an array and needs to be reshaped. Okay, so if you haven't run that code already, you need to do that in order to use the linear regression. So the national income has to be reshaped in an array, and then we need our exports to also be an array. Okay, then we can use the linear regression function. If you're getting an error with the linear regression function, it's probably because your national income hasn't been reshaped. All right, so let's fit that. Let's find the coefficient, that's the slope. Notice it's 0 here. Then give us the intercept, it's 100, which means our formula is x equals 100 plus 0y, which is 100. That's the horizontal line we see for export spending. Let's do the same thing for import spending. Let's convert it to an array. Then let's use our linear regression function, fit our linear regression with national income on the horizontal, imports on the vertical. Find us that formula for the line. Find the coefficient and find the intercept. So here we see is an intercept of 40. So that's an autonomous import spending. If income is 0, we are still spending 40 bucks on foreign goods. As income increases, so as Y gets bigger, then for every additional $100 of national income, we will spend 10 bucks on imports, or for every additional dollar of income, we're spending 10 cents. That's that slope here of 0.1. And so you can see here, here's that autonomous import spending of 40, and then as income increases, we are import spending 10 cents of every dollar. Okay. All right. Well, this gave us a formula for exports and for imports, but what if we want a formula for net exports? So we had to look on this graph here and compare exports to imports to see trade surpluses, trade deficits, but we could have a formula that tells us whether there's a trade deficit or a trade surplus. And remember the aggregate expenditure function, the last part is x minus IM. So let's go ahead and find x minus IM and a formula for it. So we're finding net exports. Well, we already told our Python code how much x's are and how much IM is. So we can create a formula that says x minus IM now that we have entered that in. So this works because they've already both been converted into an array. So we have x as an array, IM as an array, and so we can say just find us nx. And to see what it comes up with, you can say, okay, show me nx. And so here we have our nx. So if I go back here, x is 100, imports are 40, so net exports here would be 60. When exports were 100 and imports were 50, the net exports were 50. So let me go back and you can see 60, 50, 40. So as our income increases, net exports go down. Let's plot that information. So plt.plot, national income on the horizontal, nx here on the vertical. Mark it with dots, label the x-axis national income, label the y-axis net exports, add a grid, and plot it. So you can see as income increases, net exports goes down. Okay, let's find the formula for net exports. We're doing our linear regression. We've already reshaped national income so that it is appropriate for the model. And so all we have to do is just fit national income versus our net exports and find our coefficient and our intercept. So here we have net exports, X minus IM or NX is 60 minus 0.1Y. So as our income increases, the amount that we import, and imports, the money is leaving. So that's this negative part here. This negative 0.1 times Y says that for every additional dollar of income, 10 cents is leaving the country. Or for every additional $100 of income, 10 bucks is leaving the country. Okay, so this helps then tell you whether you have a trade surplus or a trade deficit, because we can see here that a national income of 600, we have a balance of trade. At 700, net exports is negative, so we have a trade deficit, money's leaving. And at lower levels of income, like here at 100, we have a trade surplus. More money is coming in than is going out. Before we leave the topic of net exports, let's talk about what would cause this graph to shift up or shift down. And so you saw this in the previous videos, but if there's a change in the exchange rate, okay, so remember we're looking at here exports minus imports. When we talk about a shifting of this graph up, we're talking about people in other countries buying more of our stuff or us buying less foreign stuff. So less money leaving, more money coming in. So that means that when foreigners have more income, they will buy more of our stuff. It goes up. If our currency is worth less, so let's say the Canadian dollar depreciates, loses value relative to, say, the US dollar, then Americans will buy more of our stuff because our stuff is cheaper, and we'll buy less of theirs because our Midas doesn't go as far. So when the Canadian dollar depreciates and the American dollar appreciates, then our Canadian net exports goes up. Okay. We can look at changes in foreign taste. So if people in other countries like our stuff more, then they'll buy more of our goods. And we can also look at relative prices. How much do things cost in, say, Canada versus the US? So separate from the exchange rate, just maybe certain goods are cheaper. If our goods are cheaper, then they'll buy it from us and the exports will go up, and we won't buy it from them, so the imports will go down. That shifts this graph up. The graph goes up when other people buy more stuff from us and we buy less from them.